quickly begin, I'd like to introduce our star-studded panel today. Two of our most precious leaders in the business. And if we can move to the next slide, I'll quickly introduce Ashish, who is our Chief Technology Officer and also the moderator for today. Ashish comes from over 20 years of experience in the technology industry. His pet peeve or his favorite things to do is around new and emerging tech. So if you have any trivia, any questions, anything in mind about anything to do with emerging tech, Ashish is your man to go. And of course, he spearheads all technology excellence projects within e-Zest. So welcome, Ashish, and thank you for agreeing to do the session for us. And over to you now. So everybody listen in. If there's any questions, any inputs, please post your questions here. We'll be more than happy to take them up. At a logical juncture, we will sort of stop. We will take questions in. We'd like to keep this really interactive. And we'll begin now, and we'll take logical breaks to take sort of questions in. And otherwise, if you have a more overarching question from a more transformational element, then let's hold on to those questions till the end. And we've kept about 20 minutes for us to do a quick Q&A with all the audience. So thank you all again for joining, and over to you, Ashish.
Sure. Thank you, Janki. Thank you all participants. I hope you are staying strong and staying safe with the current COVID situation. Maybe I just want to move ahead, introduce our speaker today, Jaywant Deshpande. He leads innovation and global deliveries in e-Zest. He's having 22 plus years of experience, started from the technology background as an architect and a solution person all the while. Technology has been always his passion, and yeah, having that enterprise view is something that is his uniqueness. Like he had been associated with us as one of a founder, basically. So yeah, more than 20 years now as a e-Zest stands, 20 plus years now. So welcome, Jaywant, for this discussion. Maybe I'll just list down the agenda, what we are having a discussion on today. So we'll talk a bit about what is data engineering, and then of course the evolution part of it is interesting to see how we reached so far, but more interesting part is that, okay, how do we go basically from here, and how can we ensure that, okay, we drive innovation in the organization, some of the use cases, and then we'll talk a bit about what set of tools that we can have for this new age data engineering, which we call as digital data engineering as such. So over to you, Jaywant.
Yeah. Of course, question and answers at the end.
Yeah, absolutely. So I didn't put it for the reason that, okay, I'll let the questions come in all the while, and I'll keep interrupting if you're okay to keep asking the question, to fill in basically wherever I see a need is there.
Right.
So welcome.
Yeah, so
move ahead.
Yeah, so please feel free to ask question. I think Ashish can ask on your behalf. I would like to actually take them as we discuss the topic, because if we leave it to the end, we lose the context. Anyway, thank you very much for joining. Good morning, good afternoon, or good evening, based on where you are in the world. Really glad that you all joined. I hope you find the session interesting. Let's get down to the subject quickly. Right. So I always think that it's best to start with a definition, because people have different meanings to the same terminology. And I really thought that it would be pretty easy to find this definition given like so much material out there online. But your surprise, my surprise, I didn't find a definition for data engineering that I can use, or I actually couldn't find it. So I had to make one. So I'll just quickly mention what I really believe about data engineering is all about letting organization make informed decisions and take appropriate actions. And whatever is in between is we term as data engineering. So you start with data, and today our organization has gathered massive amounts of data for years from various systems, both data inside the organization as well as data available from external sources, structured, unstructured. Now leveraging that to business benefits or taking actions or helping people make decisions is what we can do with this data, and that's all is data engineering according to me. And it might be slightly different than some of the viewpoints, which is why I thought I would clarify it first. Now you might have noticed that we talk about digital data engineering, and you might wonder like what is this digital data engineering and how is it different from data engineering? It's actually essentially it's data engineering, but in our digital era, it's digital plus data engineering put together. Using data engineering, we solve the problems of digital world, and by digital, people mean engagement with customer in novel ways, transformation of business in a innovative way, and that's exactly what we mean. Using data engineering and the power to sort of turn an organization into a truly digital organization. That's basically essentially what it means to us. Now, this is the landscape I would call of data engineering. And if we start with the leftmost side, we have like events and data. And events, according to me, is a very essential ingredient, just like data. It has tremendous value. I believe many organizations have not really exploited or utilized the opportunity or power that we can leverage from actually using events effectively. They essentially carry the time context, so it's in the real time with the data and the context. You can actually solve problem in real time, much more seamless or easier manner, and you have to actually, of course, use it appropriately. We have few more slides or use cases dedicated to how we can leverage events along with data to completely have a new look on how we design our structure systems. The aspect that I touched in the definition, and I think it's very interesting, is to what do we actually do with the data? We have lots of data. People talk about like this data as an asset. Data is a true differentiator between businesses and so on. But exactly what does that mean? And we know that we are collecting like so much data these days. Just as a comparison, like in one single day, we collect as much data as we used to collect in a decade, maybe few decades ago, like between before 2000. That's the same amount of data we used to collect in a decade. So that's the scale of growth. It's really exponential, and there's no reason to believe that it's going to start. It's probably continue in that path, and that is what in a way driving the evolution. I will actually like to give an example of what I mean by data getting transformed into information or knowledge, and what exactly is the subtle differences between them, because it's very essential when we actually solve problems. So to give an example, like date of birth, typically we capture, you will find in many databases, that according to me is the data. Just on its own, that date is not that meaningful. Even if you give it to an AI model, it will not be able to make a lot of sense from it. But the moment you actually subtract it from today's date and you get like an age of a person, it suddenly starts making a lot more sense. And that kind of transformation, actually converting data into something really meaningful, is what we sort of do all the time to actually do normal processing, to feed it to the model, or to make decisions. So that process of turning raw data into meaningful stuff is basically information. There is a difference between the information and knowledge is where actually the AI or machine learning, those kind of things come in. Is because knowledge is nothing but patterns, and AI is really good at identifying patterns. Only problem with AI is it can find a lot of patterns, and there are so many patterns that exist in the data, but you are not really sure whether the pattern are really the truth, because do they exist even when the data changes or the data that you are not seeing. And this data scientists typically use a trick, which is like they split the data set, they feed only partial information, find the patterns, and check which patterns actually remain constant in the data set that the model hasn't seen. And when you find pattern that really exists outside your data set, that's actually knowledge, and that you can capture. And that is, today we have technology and it's very much in use. We use AI/ML. And we'll talk about some of the challenges when we try to scale and build a knowledge that can enhance business ability. And that's different from just having like building one or few models. And we'll talk more about it later. And the last part, which we typically term as BI, business intelligence, it's basically visualizing the data and the actions. Normally, if you see, people have focused data engineering to create insights, to create reporting or dashboards and things like that. But just the sheer amount of data, the variety and the amount of, for example, reports or dashboards or the insight that you can create could be overwhelming. And just watching, getting those insights or looking at the dashboard, not only just expensive, you need actually an intelligent pair of eyes looking at it, it does nothing. So what is really important is actually getting actions, because that action turns into dollar tomorrow, right? So that link is very important, and today it is highly dependent on people. We actually expect people to take action based on the insights that they find looking at the data. But it really doesn't have to be that. Especially with the advent of AI, we can actually learn what kind of insights people or what kind of actions people take, learn from them. And there is tremendous potential of short-circuiting and getting directly to the actions. And when we take this action, we need to actually build systems where we made these actions possible. And that is another area which is less explored, or we have not actually seen many systems built in that fashion. That is another interesting stuff that I really want to talk about later. I just want to take a pause. Ashish, any questions on the previous slide so far?
Yeah, just on the slide back, I think you made an interesting point that, okay, as people take action, and those actions in return basically generates events and the data, which again feeds to the system. And that way, the ML can actually help you identify what actions you had been taking, under what scenarios, under what circumstances. So that's feed back part of it. Another interesting piece, what I see you had presented was that, okay, it's a data processing team, which is a set of data engineers, a data scientist, BI, along with a DevOps on a cloud. They collaborate together basically. So that's the one of the representation, one of the thing that I see. You have circled it, the data storage, you have circled it like a treasure basically. That's what it is. So.
Yeah. And another interesting aspect here, which I didn't touch, is the whole cloud and DevOps automation. So that plays also critical and central role. And the fact that these teams working together actually create a lot of business value, because when you solve the problem, you really don't know which department, which side the solution come from. So it's very important to have this collaborative team. And I've seen companies where you have like almost like walls between data scientists and data engineers or the BI. And what we find is it works tremendously especially when you are working on complex problem solving. You have to sort of make sure that they work together, they collaborate, and focus is on solving problem, not like progressing just the discipline that they are involved in. And that's also something very important that we have seen working. The reason DevOps plays an important role is because as a data scientist or data engineers, you need access to your organization assets, be it data lakes, and you need environments where you actually can process large amounts of data, and you need cloud environments and stuff like that. So it is very important that we automate all that process and don't waste the precious and expensive times of data engineers or data scientists in various kinds of approvals, for whether it's security reason, whether it's just a rate tape. It needs to be all automated so that they can get on working. They can automatically create workbenches which live till they do the job. They automatically sort of brought down and things like that. That's very important, because that's going to help in optimizing the cost. Plus, you can actually have common, consistent governance and so on. That's something maybe I would like Ashish to talk later, because that's a very interesting area in the data engineering space. Especially because dealing with large data means you need to be sensitive of cost. It is very expensive to actually do computing, be it whatever in-memory computation that we generally have to do. costs a lot. Same because of large volume. You need to be mindful of cloud, not so much storage cost, but yeah, you need to still be mindful of the cost, especially of computing. All right. So let's look at the train, and it's very interesting. And what I find really amusing is like how the entire flavor of the trains changes one decade after another. We actually born in RDBMS era, if you like. That's where, as a developer, I was born. So, and I believe some of you or many of you might be born in the same era. And what I found is it was like amazing. Like things were a lot simpler because we were not doing so much distributed computing. The data was sizable enough that a machine could handle. And that's really where the success of RDBMS, or to some extent even OLAP technologies, was, because at least those 2 decades, it was fine that the storage and querying remain on the same box. And as we know that the volume of data grew, that has started becoming problematic. OLAP came up with bigger boxes, a lot more memory, and a lot more licensing fees. And that's where, in the last decade, several solutions have brought in. So it started with Hadoop, presenting pretty much low-cost storage, ability to distribute the data, but still combine them using MapReduce or Hive, so that you can still fire query and get it. But then what people find it is actually going back to almost like pre-database era, where things are a lot more complex and the complexity needs to be handled by developer. So what we saved in licensing, we actually had expensive teams, so much complexity, challenges. And then as the decade progressed, we had solution for a lot of these things. Spark came in, Kafka came in, which were like much more simpler to deal with. It's still complex comparatively, but a lot simpler than actually working with Hadoop and HDFS on their own. And then cloud came with their own low-cost versions of storage, like S3 or Azure Blob Storage. But overall, last decade has introduced so many new and interesting technologies. And the beauty of all these technologies is when we solve problems, they don't make previous technology redundant. It's actually we use the right technology for right problems. So all of this, like we still use RDBMS as much as we used to in the past. But this new problem, this big data, we came up with different solution. All technologies pretty much coexist. Nothing replaces another one. And that makes, I believe, the next decade is very interesting. So all these technologies allow us to really relook at how we solve problem. How do we create business value? And what I believe, and that happens to me all the time, that we still have the biases of the era where we were born, where we still think that, okay, redundancy is not a good idea. We need to normalize the data so that we keep an eye on storage and things like that. But things have changed dramatically. Storage is probably 1,000 or even 1,000,000 times cheaper than what it is. And we really need to completely relook at how the architecture for future should be. Would it be the same like how we build software, or there are new opportunities with all these new technologies that has come in, be it in IoT or Kafka or cloud, and this, can we really leverage their full potential coupled with the tremendous amounts of data that we have? And the beauty of data, as I told earlier, you can actually find patterns, you can get information, and that coupled with the ability of technology would be creating opportunities. And that's what I really want to talk about. Right, so I'll move on to the next slide. Before that, I'll just touch base on the next decade. Like there are a few areas where I really find interesting, and what I try to do is pick a use case from each one. Like, yeah, maybe what is like interesting, what are the challenges that we find and how we solved it. Or in the event, I mentioned about events and how we can use them interestingly to actually design the system differently, or where does business get edge or business differentiators if they want to really leverage data's potential. And one of the things companies do is hyper personalization, trying to actually, it's heavily used in marketing, but can we expand that paradigm to actually do make this like how do we interact with human in future and those kind of things. And we touch on how the cloud or some of the new technologies. And I'm very passionate about what Snowflake has to bring to the table. Maybe we'll spend some time discussing about that and how it differentiates. One last point that I would like to also cover is, given that this all those options, it's also very difficult for organization to choose the right technology. And we'll spend a few minutes on at least the guiding principle that I use, and I'll share some of my secrets. Right, so AI ML is really interesting and it has a lot of promise. And the reason I say promise, because organization has been trying and with a limited success. There are always these claims about so many AI projects don't actually get to the production, and things its initial days, things would improve. But nevertheless, I'm a big believer of how AI can be transformative in creating business value. So rather than actually talking about that, let's jump on to use case, because I really want to explain how we can sort of leverage its potential in a novel ways. This is one example where we managed to actually transform the data into knowledge to solve this really an interesting business problem. And what I tried to do is to generalize it, because I'm sure you will have very similar systems, even though the nature of the system is different, basically the way it works would be very similar. So it's like a typical backend system. You have like input data. In this case, it happens to be a claim adjudication system. So the input was claims data, output decides whether the claim should get paid or reject. Could have been simpler, but the complexity is because clients have different configurations, different plans, and system, of course, have to behave based on how the plan configurations are. And a typical client will have hundreds or thousands of different plans, and there would be thousands of such clients. That makes this system enormously complex, because it has to deal with all these permission combinations, and there are like so many rules and stuff like that. And this system like evolved over years. Sound very familiar to maybe order booking system in travel and things like that, or in finance, you have again system that has evolved over years. What is unique about this is both the inputs and outputs are 100% digitized, and that's very important. We can look at pretty much all the data that can get in, and we can look at all the data that it spits out, the output. So input and output is both data, and we have the historical sort of references available. All the historical data is available. So in other words, the data, the past claims and how they are processed have captured tremendous amount of knowledge about the system, how the claim adjudication system behaves, what it does, because depending upon what plan configurations are, and all that, you can find a lot of those patterns from the data. So now we have an opportunity. Today, any of that means you go to expert. You go to people who understand these systems, and there are not far many, because the systems evolved. They are so complex that no one person knows it all, and you have to really spend a lot of time in finding the right expert, piecing together the knowledge, and so on, because these systems generally are not so well documented. I believe this statement sounds very familiar to most of you, because I myself have seen this numerous times with different organizations from different industries. And that's where I got excited, because I believe that the kind of solutions that we have applied could be generalized in many industries and many organizations. Now the question is, we got let's say, new client, came up with his own set of plans. In this case, really big client, loads and loads of plans. We update the system. Now all you want to do is to make sure that the system got configured exactly like client has specified. And most of the time, as you know, it's not just configuration. Many of the time you have to make changes, things like that, because every client come up with something new and so on. But the point is that all we need to now focus on is testing and making sure that whether the client requirements are met correctly or not. And there is a lot of effort and time gets spent on doing rounds of testing, auditing, maybe a few other steps, so that we are pretty sure that the system is exactly behaving as client has specified. Now, so far we applied people and some kind of automation still done by people. Either you can call it test automation, or we did a lot of manual testing and applied a lot of expert knowledge to it. Would there be other way? Can we not leverage the knowledge that is already available in our data about the systems? Can we not uncover or extract the rules and check whether the system has deviated? Is the input, like the plan configuration and the claims data, is getting processed correctly? Are we find some anomalies? And if you just think about it, it's definitely possible. We can actually find those anomalies. Maybe not all of them would be correct, but you will find a good portion of them will point you to defects, and you can just like build a triaging solution after that. But you can actually build some applications that would eliminate a lot of work that otherwise would have been manually done or by depends on the expert. And it also covers a lot more ground, because when you create test scenarios, there is a limitation, like how many you can really test. But if you rely on historical data, you can never stop. You can actually keep on testing, maybe even in production or in your parallel processing environments. A lot of those things you can do. So what we did is actually builds the models on this historical data, which allow us to compare what the models think should happen versus what's happening and capture discrepancies. And that helped in this particular instance, because the volume was so much that we wouldn't have even able to hire those many testers, but we needed far fewer. So that is where it really dawned, like how much powerful this can get if you can get it right, and it really can solve some serious business problem, especially when we are dealing with a scale of data or transactions that with over a period of time, it's going to get more and more difficult to rely on human to scale to that level. And that's basically what is the one example how we can extract the potential from your historical data.
So, Jaywant, I do have a couple of questions over here. Firstly, I just want to summarize it. I think you explained it very well, that if the input and output both are digitized, you can actually build, like if we have built the model, you have built the model to find the anomalies, and that way reduce the validation efforts drastically. But it can be as good as an anomaly detection, surveillance kind of system, or requirement validation, requirement change validation, all those kind of stuff as well. That is fantastic. Just a question very relevant over here that has been asked by a participant is you have put a couple of dotted lines. What does that represent? That's the question one. Okay.
Right. Okay, good. So what generally, if you look at AI process, first you build models using historical data. So that's what I depicted. But then you use the models in the execution world, and that's where we pass the input. The dotted line inputs mean actually it gets all the inputs, both the client requirement as well as the claims data in this case. That serves as an input, and it sort of predicts what should be the output. And that output data, which in a very simplistic form, I said it's paid or reject, but in reality, it's like probably few hundred attributes. And that's what we compare and say that, oh, okay, is it really, do we find any discrepancies? And if yes, then is that we go back to the requirement, see which requirement actually we think hasn't got implemented correctly. And we just check that particular aspect of requirement, because it's like thousands of land, so many configurations. Getting down to that specific level of detail is very important, and that's what we can get down to.
That's perfect. So it is like the forking, basically the input data is passed to both the systems as well as the output is compared, and that's the connection
Right.
you are representing.
That's right. Yeah.
That's good. The second question is not very specific to this slide, but in general looks like for a big data or in general a data engineering thing is that what about the privacy laws, and do they act or would they act as a hindrance to add the business value to client as such? Uh, I mean, if
Okay, that's a good question and a very interesting one.
yeah.
With data, there comes a baggage, because depending upon which industry, like in this case, if it is healthcare, of course you have to worry about PHI and sort of protecting the data. But the beauty of, at least especially when you work on AI project, is the AI project doesn't care about the specific information. AI project actually cares about whether are these two values same or different. They don't need to know what is exact value. And just to make it easier, most data scientists starts with first encoding the data. And the moment you encode all this sort of sensitive information or personally identifiable information, you don't really need for the models. And you can always go back to them when you want, but the model or this sort of processes don't need it. So the pattern that really works well is you can actually have all this sensitive information in your, maybe, I don't know, some companies still use on-prem, but what we really think is once you encode the data, you can actually take that data on cloud, and there you can run this heavy computing, because the AI is very computing intensive. And then, for example, when say once a week we refresh the model, cloud really comes handy. And because cloud has all the encoded data that you shipped, it does not have any business meaningful information anyway, but the models can still give you the correct answer, which you can bring back and make business sense out of it. And that way, I think it's very easy to actually get around the challenges around security or privacy.
Very well answered. Yeah. Just another question, kind of follow up is that, okay, so what are the key, what was the question? Yeah, key data ethics practices. I think you partially answered that, but in general, if I have to put it, what are the key data ethics practices basically that can be practiced or followed as such? That's the question. Maybe I'll let you answer that.
Right. So it depends on what you mean by data ethics, but generally, as I explained, this process kind of shields or protects organization from the concerns that typically the security officer has, and so on. So that's about privacy or security. I'm not entirely sure what exactly you mean by data ethics. Maybe you want to elaborate?
Yeah, I mean, do's and don'ts of data basically, in general, in short. So just to give a perspective, just to answer the question, see over here, what we are really talking about is the data that typically an enterprise owns with their system, and with that particular system, how do they validate the system, how do they reverse engineer the system, or how do they do a surveillance of the system, are typically the use cases what we are talking about here, transforming the data part of it.
Correct, correct.
So here the personal identifiable information of the person or of the client is not needed any which way for the ML model typically. So generally, while you are giving the data to data scientist or data engineer, you probably are not going to touch those areas while you are building the model or while you are building the systems. Once the systems are in production, then the systems may use it for the action part of it. But then that is a platform which is what is built basically. So no person touches it. And those are the typical stuff. I see a similar question on the GDPR part of it as well, which in a way I addressed it, that the data which is coming over here, what we are talking about is the customer submitted data, customer feeded data basically. As an application is used, or the engine or the solution or the system is used by the by the client, that goes.
Right. Okay. So on this aspect, like once you mentioned about this best practices or do's and don'ts, I think we'll cover, because towards the end we have actually some slides that are more generic. Where I think, especially with respect to cloud and DevOps, we can cover how we can address those challenges and what some of the best practices around both data plus DevOps emerge. And the second part of this, again, going back to privacy or security or even GDPR, I think this, in a way, there is a very nice way to actually shield in the space of AI, because you can anonymize the data and still not lose any information, and that's the best part. And maybe in the next case, it would be even more clear how the encoding actually serves that purpose. So maybe I'll just move to the next slide. And this is another typical challenge we had seen in the real world. And there probably the whole encoding idea becomes even more clear. So what happened is, when we actually worked on some complex, really, if you like, we can call industrialized use case of AI or ML, what we found is that actually ML is very good when you have a bunch of input data. You want to predict one variable, you build a model for it, because end of the day, ML model can help you predict one variable. And it really works well. You can test it, it can tell how well it is working, and so on. Especially in this field of structured data, which most of us actually use, and that's where a lot of business value is today trapped, in the field of the structured data or structured and categorical data. This works well in a limited way. But when we actually look at real world problem, especially some really major problems, what we find is that you generally don't have like one or two input variables. The intelligence comes from pretty much predicting the future or predicting the whole sort of environment. So it's basically predicting a lot more variables to really bring intelligence. And so even the business case, that some complex business case we want to solve, we come up across the situation that you have to actually predict not 1 or 10 or 20, but few hundred, if not thousands of variables that you can predict, and then you can actually attack some really challenging business problem. Or you can do many things, because you could now predict, for example, a complete persona of a potential buyer or a customer having hundreds of data points, or in our case, maybe just in previous case, if you want plan configuration or output, it's like a lot of variables. And how do you actually now do that? Because when we had such problems, what we realize is, if we use the classical approach of like take one variable, identify right feature set, do this feature engineering, build models, test them, and then once we are happy, freeze and move to the next variable to predict. It would have taken years, maybe more, and a lot of effort, and it would be too expensive. And we actually had genuine problems, so we really don't know like how do we tackle this. And then when we said that, okay, so a classical approach wouldn't really work. All we need to do is to go back to data engineers and ask them, can you actually automate what the AI team does? And we had a stab of it. We tried to pretty much automate every single step, something like AutoML run in a loop, or AutoML sort of creating multiple auto modelings on the fly. It didn't work very well, but it was very encouraging, because it did work. It tell us like how good the model is, even though most of the models were rubbish. But it said us that maybe we are in the right track, because some model did work to some extent. Maybe we need to do something to really get this thing work. And when we look at why these models are failing, what we realize is, even though they are predicting one variable, what models are doing is they are actually trying to identify what really rules are in play. And when you have like multiple rules getting superimposed, the model's accuracy starts dropping. So we thought maybe if you can do it with few hundred models, why not do with few thousands of models? So we expanded the whole space. So rather than actually typically in AI, you reduce the number of sort of variables to get it. What we did is actually kind of opposite. We enhanced, but what we did is we created what we call as a micro feature, which explain or capture a granular attribute of the data. Right, and we did it both for the input and for the output. So we had like lot more variables, and then we ran our completely this auto modeling technique, and it spawned up like thousands of models. And what we found out is that the accuracy jumped to very high, and most of this, in fact, micro attributes are predicted to a very high degree of accuracy, close to almost 100%. And we were very excited, and then we sort of built a collapsing logic to get back to the output variables. And that we thought, oh, amazing. This is really something which will allow us to like scale the AI without actually having too many data scientists and building too many models manually. And now we had to do it because we had like a problem at hand. But when I step back and like when I sometimes hear some of the problem statement clients make, like what they're trying to do is they're actually trying to build few POCs of AI and trying to find which work better, and then we plan to actually productionize it. And I think, wait, why are we building POCs? Why can't this auto modeling be your POC engine? And because it tells us very well what works and what doesn't, and things like that. So there are like so many interesting ideas that keep popping out when we have a conversation about some serious use cases of ML. So I thought it would be another interesting experience that I would like to share.
So, I think this is great. So Jaywant, just to get the clarity for all participants over here, typical ML modeling technique is that, okay, yes, you try to reduce the variables so that your model is reliable. And you typically are building, a data scientist is working on creating a model as such. Of course, you are experimenting with many things. You see that, okay, for a given problem, for a given thing, which of the selected models across different algorithm, which one is working. But here you have turned this down the other way, basically. So you are actually taking as many variables as you can have, or you possibly can have, and you are creating those many models, basically. So you're creating a model factory in a way.
Yeah.
Is that right? Or can you explain a bit more onto that?
Yes. Yeah. It's yes and no. So yes, we are actually feeding a lot many variables rather than actually eliminating some. But if you look at each micro model level, so each micro model does that selection, and that is automated. So it's basically the data engineers or basically the code that does it rather than a data scientist, and it selects. Because the features are granular, it is actually much higher chances of actually selecting the right micro features to be included in the model. And then it actually can try different. So what it does is it also try different algorithms and find which ones work best, and then freezes that and ignore all the previous results. But within the at a micro model level, that exactly still happens, that the feature selection to really few features does happen.
Yeah, we got it, because that was one of the questions that, okay, have we automated the AI model creation? And I think you answered that thing. Okay, I do have a few questions which I'm keeping it for later, because those are now related to the previous few slides. So yeah, I think for the sake of time, we can move ahead.
Sure. Thanks. Right. Okay. So now we move to another very interesting topic, which is how do we leverage events. And of course, you are familiar with today the technologies that allow us to do streaming, stream processing, Kafka, Spark. Even we had like amazing experience with technology called Moderator and so on. The whole IoT actually sort of evolved the space of stream processing. And when we look at when we build and looked at some of the IoT systems, I couldn't stop thinking like why it has to be a sensors at the one end and why it has to be like alerts at the other end. Can we not actually take this pattern and take it to business application? So one of the way we took this sort of technology is turned our applications into things that sort of push events when any changes happen to those systems. So pretty much like a system works like carrying few sensors and spitting out events in the just like sensor do, and then use that data to actually build processing on top. You can actually turn those events into really meaningful event, a process event that people can subscribe to or systems can subscribe to and do the updates that they want, or turn them into what we call as a task or action that can be given to users or users so that we can sort of build systems that work differently. And in the next couple of slides, we'll talk about those. But let's look at this pattern like in detail, what is possible with events. So far, when we build systems or software, we had like user pretty much as a driver. So user actually logs in the system whenever he wants. He decides what activity or process that he wants to start. And system's job is to actually capture that, and so it manifests like a data in the database. In real-time sense, we actually get events. We don't do very much with that. But this way of software development is something we all are familiar with. This is how most of our OLTP systems are built today. Now, what I did is actually completely flip the paradigm, change the role of each components in the system, and pretty much now we want to do it the other way, where we say that we already have like data and we have this really meaningful events that tell us really what is happening now so that we can react to it, we can respond to it, or whatever is the next best thing we want to do. If this happens, we want to just get that done immediately. If that involves another system, we'll tell that system and make sure that it gets done. If that involves people, we'll tell them that, okay, this is the next task pending onto you, better get it done. We not only just notify, we pull all the context around it and prepare a task for the user to do so that the user also doesn't have to go to 10 other places. In that one interface can do it. So that's the idea. And we said, okay, let's build some system like that. And rather than actually explaining the sort of pattern or technology, I'll explain it using a use case. Maybe that give an idea. So a recent use case that we implemented is for a travel company to actually collect debt collection process. A typical flow would have been a user logs into the system, find which hotels, how much debt, what is their phone number, and decide, let me make a call. Based on the conversation, you decide, okay, actually they ask for the details of transaction. Let me actually download the transactions, put them in Excel, attach it in email, use a particular template, send them. A typical process in a team that handles that. And we said that, okay, how would we model it? Now we had like developers building this system, building the front end, building the back end, the whole MVC pattern. And we said that, okay, for us, it means that we want to actually create a flow and we need an event. In this case, the event could have come as a CDC, but in this case, there was a existing application that used to generate Excel files where these details needs to be, the details were captured. So we actually load those Excel, turn them into event, and we build this flow where the activities of what should happen next. So let's say step one is for the system to find out which hotels should be prioritized first. And you can decide that, for example, how much amount of outstanding amount you owe. So implement it that way. Then we realize actually there is a commission percentage which is different. So let's just modify that and prioritize hotel now a little bit differently and apply the commission as well. So that becomes your first activity for the system. Next activity is so that, okay, once you know like which hotel need to be called, we need to package that information and push it like a task. And there is a one very simple interface like Twitter or we are familiar with the feed kind of interfaces. So it's just a generic interface where we get these feeds from system. So a user one gets activity saying that, okay, this is the hotel you need to call. This is the supporting information that you may need on the call. This is the attachment for transaction in case you want to have a look at it. So all the details that user may need, we package it together and send it to the user. So user doesn't have to switch different application. In one place, all the context is available. All the user needs to do is just log in into one system, see what is his first task, which is, let's say, calling a particular hotel. He called that hotel and find out what the status of date and things like that. And then tell the system back, what is the outcome? Did I make a connection? What is the next step? Do I need to send email? What information or what template? It selects that, the task returned back to the system. It's the kind of exact reversal of our typical request response paradigm that we build application using HTTP. We pretty much has to reverse it. So rather than it's a request response from the user, it is like the system making a synchronous call. And one beauty of this approach is then the system does not differentiate whether the task is performed by a user or performed by another microservice or performed by some system component. It really doesn't matter because the system doesn't need to know. Today it is a user one, tomorrow similar task can be passed to user two. Next day it can be a bot that doing it. Day after it could be a component of the system or the AI model have already learned the user behavior and things that it can predict or do better than user and it start doing it. The system doesn't undergo any such modification. So that's one beauty that we find. Another thing that we realize when we build this pattern is that the end-to-end workflow is just captured at one place. So there is really a central orchestrator, which very difficult in the world of our request response to, because the whole work process is always fragmented. And we don't realize it, but that creates a lot of complexity because what happens is the knowledge of analyst or the flow, the way analysts describe, undergo a big transformation when the developer develops it. What we find that we don't have to do it that way because what analysts tell us that this is how the process is, we implement exactly similar looking flowchart into the system. And that makes it very easy even to modify it or add new steps. Another beauty which we haven't done, but our plan is to actually monitor now performance of each activity, performance of each user, like which user is really good at doing which activity. And then can we dynamically change the distribution of those activities to the users, right? Can we add even the models like what is the propensity of hotel to pay the debt? Can we not prioritize them more? And those kind of changes are very easy to add into the flow without changing rest of the system. So we just thought that this would be a very interesting sort of a pattern that we have built, and the application that we have built so far had a lot of promise. And again, as I said, it's pretty generic pattern that we thought is very valuable. Again, what we try to do is how do we leverage the data and events to solve business problem? And really it stems out from that. How do you actually completely take this data and events and build systems on top of that, which takes a different route or approach to business problem solving.
Yeah, so Jaywant, we do have a few questions here. One is a very nice question that, okay, do you mean that here the user is not using the system, but a user is a part of the system itself?
You can think it that way. That's an interesting way to look at it, because now we don't have this special status to the user that he somehow controlling it. Why our systems are complex? Because I think there are effectively multiple orchestrators. And it's very difficult then to get one view because the system try to orchestrate what is in its control, but then you have an outside orchestrator that comes up and actually move things around. And it's very difficult to build a system that deals with these multiple orchestrators. What, as you rightly said, now the users are treated just like another component of system. We really don't Here they don't have any special tasks. It's the system drives, the data and events actually drive what needs to happen, and things can be made to happen in the best interest of the organization. You can always calculate what is the next best thing to do for this user. How do I optimize or enhance the productivity, or every single minute and hour this user is spending, what is the best way we can utilize that, so as with components of the system. So it's much easier to actually build productive systems.
That's good. Thanks. We do have a few more questions. Amit looks like had made a very apt question that, okay, can a user make changes in the Twitter-like handle on the fly? Basically, can I subscribe to a topic of my interest
so here I spoke about task, because they actually generate business value and it's very easy to see that happens. But there are a lot of things that can happen on the interface. So currently we have actually really few use cases. But one of the things that users can do is to subscribe various topics that they have access to, and just think that they are interested in, but not only just subscribe and view, but they can actually share, just like you do in Facebook or Twitter or Instagram. You just shared or forward not only these events that you find interesting, but even the task. For example, you think that you are incapable of doing this task, you can pass it to your colleague or manager, or just ask questions with comment, and that kind of collaboration can still easily happen on the system. But as I said, it's like a different way to build organization systems, but more like what we are used to. And there is a reason why we like and use Facebook or Twitter and things so often. And the secret is in the effective use of events, because it's down to human behavior. And the best way it was summarized is by Fogg's behavior model, that user behavior is actually a formula. It is a formula of motivation multiplied by ability multiplied by trigger. Behavior is equal to MAT. And that trigger is so important, but if you see the left-hand side, the present world, we don't use this trigger. Now we have those triggers in the form of event, and we pass those triggers along with the context, the data, which gives, or the task that gives user ability to do things. This combination works really well. That's why we get hooked on to this social networking thing, because they keep on sending the trigger so that we go back to the system. And that's exactly the paradigm that we want to leverage here, and plant trigger or plant this prompt, which makes user to do right thing at right time.
That's right. That's correct. So, Jaywant, one more question: that event-driven is data dependent or not? I think the answer is simple. Yes, it is.
Absolutely. So it's the data and event together, and I'll give you an example. So the simplest form of event is just a notification. You got notified. But then the idea here is that when you want to get a task done, either from system or from a user, you need to provide the entire context, all the variables that the user or the sort of object need for doing further processing. And we need to pull them together. And that you find it in the data that's already available. Sometimes they are already part of the event. If not, you go and pull them, package them in the form of a new event or a task, present it to the someone who subscribe or someone you want to distribute it to.
Yes.
So I know these are very interesting topic, and pretty much each topic deserves a webinar, but I think we have few more to cover. That's why, sorry,
that's the time check basically.
We
are towards the end. Basically, it's 8 local time, 8 to 5. So there are a couple of questions more, but for the benefit of finishing this on time, I'll skip those for now. We'll put it at the end. Go ahead.
So we talked so much about event, but it may not be directly relevant, especially for those who have not dealt in event a lot, and how does they are important now, or what technology today actually makes it possible. So it's one of the framework that we currently use to solve problems of these natures or apply this pattern in multiple problems. So I'll explain you how we currently capture events. So there are existing all this OLTP application, be it ERP or CRM and all that, all these applications. What we do is we actually put a probe. So we have a technology called Kafka Connect that monitors CDC. You can use anything else, that doesn't really matter, but all you need is a CDC that sort of notifies you of any updates along with the data that got updated. Most databases have these features. If not, again, as I told, there are technologies that let you do it. So whatever business event happened, whatever happened, basically events capture that as a fact, and that comes to you. The reason I call it fact is very important. The way actually we deal with it, that we say that once we receive something, that's a fact and you cannot change it. So we are actually in the space of completely immutable data or immutable events. If you want to do anything, add anything, you actually create another event and add more information or change something, but you don't go back and change the event. So that is how we collect the event. The brain is basically the orchestrator. And here that the idea here is that today, not just because of the data, but because of expectation, user, for a lot of reasons, the systems or the organization system, especially in large organization, has really become very complex. And a lot of time when you see complexity, I go back and look at how nature has solved this problem, because nature has dealt with even bigger scale of complexity, and normally nature come up with optimum solutions. So I looked at solution how humans deal with the complexity. Human have this centralized brain and human have the memory. I thought let's do exactly that. So these events and data are actually put together in what we call as a memory. And the reason I call it memory is that we just don't store the data as is. And maybe Ashish, some of your last question about this data ethics or the pattern and do's and don'ts can apply here. What we do here is when we do get the data, we store it in the raw format. So we should always know what actually received. So things go wrong, we have an ability to correct. That's very important. But next, we looked at this data engineering that turns data into information. Just like memory turns whatever information data we receive, it immediately turns into information, it stores the information. It also identifies the pattern and store those. And so we actually try to do all of that and call it a memory. So it's not just a data anymore. It's not just a data store anymore. The data actually captured along with relevant information, with relevant connection. If there are patterns and we use AI and it enriched the data, all those data points got added. And now that this collective data sets we term as a memory. And now we have this central orchestrator, which has this understanding of processes. There are two ways. One, you have some analyst who feed the process. I showed you that workflow or the flow chart, pretty much a similar thing that get fed into it. There is a stream processing engine that actually work on top of events from this various system. Because when something changes, you want to do things. So most of your tasks, or I would actually argue all of your tasks actually get done using the trigger, which is event. Just like humans don't do anything without trigger, I believe even systems don't do anything without trigger, and those triggers are naturally present in the form of events. Some trigger you will have to plan, because some of you will question like, oh, I have got this batch work, I have to actually find today what needs to do, and those triggers are basically date change. So 12 o'clock, date change, and new day, you want to do something. You can put a delay if you want to do it 9 o'clock in the morning. So I believe in those are triggers, because the time is moving and time is giving you that trigger. So triggers are always present. The question is whether you use those triggers or not. So given that, it's basically a lot of this stream processing. Each application, pretty much as I told you earlier, we treat them like IoT things. This brain and memory act like an IoT systems. What it brings out is this task and event. We discuss about it. It doesn't care whether it's worker, then if it is people or employees, we have this interface, a very simple interface, which undergo no changes depending upon what business process you implement. It just doesn't care. It just delivers all tasks in the same manner. That makes the development work significantly reduced. So you can actually compare it to something like a low-code thing. But just like tasks, you can actually put events. We use the event pattern a lot also generally what happens in enterprises, you have like so many systems. When changes happen to one system, you want to propagate that change to some of the downstream systems. And that itself is a complex integration problem. And I've seen organizations using really, really complex way to solve it, like putting together another system called MDM and things like that. But the way we handle this problem is just real-time event. We have this processing to know which all system needs to update, how they refer to this element of data, provide them that those kind of event, they subscribe and update themselves. Very, very easy, and it builds, it adds on to that. So there are like very different kinds of use cases we could solve with this pattern. Right. Sorry, I should take a quick pause. So if you have any question.
As I said, for the sake of time, let's just move ahead. We're running short of time.
Right. So the last two use cases were highly technical, and actually I like to actually look at businesses as a whole, business value, and sort of what gives business competitive edge. So of course, the topic is like how do we give competitive edge using data engineering, but also we need to have perspective from business perspective, what they want, what are their complex problems today, and what will give them really competitive edge. And I thought maybe I'll just pick one or two cases where we have also had some experience of dealing. One thing that really strike me out, like this thing called hyper-personalization, this ability to actually build solutions for one user at a time, and actually you sort of provide him the content or produce the services or offers really targeted to that one person. There are others also refer it as micro-targeting. And there are like famous and infamous cases like Cambridge Analytica did it with Facebook users and targeted based on data. Really, you can start seeing the potential, like how much impact that it can have. An organization today really want to leverage that to get most from the customer behavior. How can you actually get customers buy-in? And all this talk about, we're talking like this data differentiating businesses and all, I think it's boils down to here. How can you push the right thing at the right time to the right person and all that? And that means immense data engineering work, because you have all the data, you know the customers and things like that. And how do you actually build systems that would allow you to do that? And we have also looked at some of the system clients have built. Another important aspect, which I actually captured in the last question, is the cost. Because we are dealing with so much data, and we are actually having another big dimension of your large number of customers, their behaviors, and it could go as granular as their single click or view time on a page. It's really what we are dealing it with, massive data churning. And if you don't pick right technologies, if you don't pick right pattern, the cost really blows out of proportion. And that can happen. And that's very important, that how do you actually sort of build such system at scale. And I thought, at least means I don't have like a silver bullet, because the answer really depends on your individual business case. But at least I thought I'll spend some time in sharing my thoughts in these aspects. And some of the learnings I actually had in my experiments with data engineering. How can we leverage data and events? So I'll not leave that pattern of how do you use data and events to drive hyper-personalization. And here, what I believe is, I've seen people pick a use case and try to take an approach use case by use case. And the problem that I've seen with that is, there are some intermediate important steps, and I just showed one of such steps. But there are like intermediate data sets that you build. In our previous example, we could call it like this memory or knowledge that this organization ignore. And what you find is, in the first use case, it's always very expensive, take long time and all. But the idea is, don't just get focused on a use case and try to solve use case. Find what assets you are building for the company. So in hyper-personalization, the most important asset is the richer customer or the user persona. Like how many data points you can collect about the user, because you don't know which data point would require where. And that is like an important intermediate step. Not only it will actually allow you to extract more value from this whole paradigm, but it will be a lot more cost effective, because a lot of these things you will otherwise have to do repeatedly. And as we discussed earlier, like it's computing today that gets really expensive because storage is really, really cheap. You have all the data, but when you compute, just make sure that you use that computation. And in this case, I gave an example, which is pretty much will appear in every hyper-personalization problem, is this enrich user profile. And rather than actually package it in your use case and do in silo and somebody else trying to build other data points for his use, eventually you will actually end up with doing a lot of repetitive tasks. The way I look at this problem is there are two steps. First step is you build this intermediate data assets, let's say user or customer profile, you enrich it, you initially enrich it for your use case, but then there are other models or other ways to actually enrich it. And you don't have to use AI to enrich. You can actually use rules, you can find information available and so on, but there is also a larger element of ML to learn from, for example, user behavior, because that's where they differ, and add those data points. Then you apply sort of triggers, which is events. And those become very important here to actually implement your use case. When you couple events with this enriched user profile and many similar such data sets, you can actually then try to create targeted messaging. If it would have been customers, maybe targeted offers or targeted content. Whereas I don't think this pattern stops at customers or marketing department. You can bring it in within your organization. You can actually do micro-targeting for your employees and see what actually works best for them, what makes them most productive, what thing they are really good at, and actually allocate the use cases or task accordingly. So I think that is another phenomena that would organization will use in next decade, and that's another very powerful use case of data-driven or data engineering. So any questions so far, or we move to the last sort of use case that I want to touch, is the role of cloud automation or DevOps automation in all this. I think we touched some of these points, but what we need to be sensitive of is the security, because you are dealing with data and data will have sensitive information. You have to deal with cost, because you are doing really heavy lifting, whether it's computing, data transfers, and so on. And that's where I think this automation is very important. Some of the limitation, like a typical data scientist or data engineer, it requires access to different data assets, different data lakes in your organization and things like that. And most of these, of course, naturally restricted. And I've seen these really sort of valuable and expensive resources are constrained and not actually become productive because of they lack access to certain data sets. And I think that is a problem that we can really easily solve by creating this automation, making sure that we sort of have right policies, governances, security things in place in how they get access to data. If certain things needs to be made available only after anonymizing it. And as I told you earlier, for example, data scientists won't complain. We can do that pretty much automatically. We don't have to actually have it manually supervised. That's one aspect. And on the cost aspect, you can actually optimize the timing and the usage of resources for the workbench that data scientists or the data engineer need for their day-to-day use, be it whatever tools they need, and making sure that we don't have resources that are underutilized or not utilized. Actually, to be honest, Ashish, who is with me, fortunately, he's really a guru in cloud and cloud automation, and we have done several interesting use cases in this space. Actually, I really want Ashish also to share his thoughts in how we leverage it, especially in the context of data engineering projects?
Sure, Jaywant, thanks. We do have 5 minutes. So, yeah, quickly, basically what we are talking about is that, okay, data engineers and data scientists, these are valuable resources, and to make them up to speed, you need a playground for them, a workbench to be created where, okay, the access to the expensive cloud resources, because we are talking about access to the big data processing resources, cloud resources, as well as access to the precious data. So those two need to be managed, and that's where a typical thing involves at a business level collaboration between these different stakeholders, like a data scientist or the project head, raising the requirement as to, yes, I need access to this set of data sources, I need access to create this kind of clusters and things of that sort. Then you have got a data owner, people who are responsible for that data, providing the access, validating the access, having the sponsorship of the things done, the infra admin part of it, want to ensure, want to give the access to the right cloud, right resources, and all that sort of stuff. So that once that collaboration part of it is managed, then the latter part is a cloud automation side of it, where, okay, infra provisioning, deprovisioning, changes of the states, all of it is managed. And typical thing is that, okay, so you provision the resources, you do the configuration of those, you give the source code management access to it, you harden the endpoints as such, and you do the verification of the environment and pass on the information back to data scientists. And then under the hood, basically we have used and we have deployed the solution on Azure as well as AWS. We've used Terraform extensively, Jenkins, of course, Jenkins jobs are being used, and for code repository part, yes, Bitbucket as well as Git was used. So that's in nutshell what the solution is basically. Jaywant, can we move? Yeah.
Thank you very much.
Yeah.
Now the last point, and we'll quickly mention it before some of this is the question that I get really often. Like we have this massive workload on Databricks, and let's say we have Snowflake. Now we don't know whether we should do it in Databricks, we should do it in
Jaywant,
Snowflake, or do it in Spark versus this. And honestly, you don't really find a lot of benchmarks available here, and most companies are really struggling. And there could be a big differential in terms of when it comes to cost.
just a minute. There is some
So this is
noise.
a quick matrix. Probably this material would be available, so we can address. But what I did is like this data volume and look at the complexity, and gives you the answer. Like, okay, most of the data processing Snowflake would probably be good at it. If you have something really complex like AI, use Databricks. If it is
Wait a minute. If you are able to hear, we are getting a background noise from your machine. So looks like there is some issue. I'll just, I hope I'm audible. I'll just take over last slide. So in short, basically what set of technology to be used over here is a function of, okay, how much volume you are having and how much processing complexity that you are looking for. And so if things are smaller, of course, no need for an expensive solution. RDBMS is good. If your volume is higher and the complexity is lesser, Snowflake provides you that musical kind of tools along with so many integration available. Likewise for Databricks, provides you both the capabilities as such. And if the data volume is low and if your processing is more, maybe you can look at the traditional ETL tools. That's in general a way to select a set of technologies as such. Yeah, can we move next?
So just a disclaimer that we are not recommending Snowflake or Databricks. It's just an example, but this is just most sort of popular technology that at least our clients use. That's why I mentioned. But you can the comparable technologies.
There is a disturbance, Jaywant. So maybe you can move next slide. Yeah. So the set of stack, just a minute. So the set of stack what we had said so far, basically from the RDBMS to NoSQL to the caching layer to the snowflakes to the data science part of it, what all things that we had been using as such. So there is no one solution fits for all. Of course, things are converging, and we do see that, okay, as a technology disruption, maybe each of the technology has got a promise of covering the whole of the gamut. Let's see, and that makes basically this technology space so much more interesting as such. Uh, Moving on to the last part, Q&A. If there are any additional questions, would be happy to address those. There had been few questions which we couldn't answer. We can take those up as well. Just a minute. Yep. So the question, Jaywant, one of these was related to that is for the event-driven application, how a brand new applications would leverage the benefit of event-driven scenario as such.
Right. So brand new would come in two forms. One, am I audible or it's still bad?
It is still a bit bad.
Let me log out and log in again. Let's see if that helps.
Sure. So quickly, I do see that yes, even a new system can leverage as such because it's the model. So the data might be coming. The use cases what Jaywant talked about was all related to the existing application and its extension where the input comes from some other system, which is typically the enterprise scenario. But you can have the data coming in from a user as well. So the kind of interface what Jaywant talked about can itself be the new way of bringing in the data as such. And then the tool works on its own. I do see one question that is, how can we address bias in AI models for building the trustworthy systems? I think the industry is experiencing and trying to resolve this thing. The whole point is that, okay, people, systems are learning from those people, and people are having those natural biases, those show up. So as we get more intelligent to identify those biases and we start learning from it, we can make systems learn them as well. So in future, hopefully we are able to build a system of identifying the biases and address those as well. But yeah, none of our slides had any context around it as such. Any other question? What's the cycle? Yeah, there was one question that, okay, what's the cycle time usually from data to knowledge? Do we have any industry benchmark? And industry interested to know this mainly for banking industry. So I think it is related to the first few slides that first or second slide that we were talking about. So typical piece is that, yes, how fast it can be. The whole point is it need to be at the 0th second basically. So before user is making a decision, you should have a system which says that, okay, so what if user takes this decision, how I'm going to respond or how I'm going to do the stuff. That's the ideal scenario. But okay, as the systems are evolving, we do have batch based or real time based. Those are like industry to industry differs. But yes, finance systems are typically, banking industries are typically ahead with it. Most of the banking industry is ahead with it as such. I think that's it from our side.
Wonderful. I think it's been an extremely interesting session. I am sure everybody's been glued in. I've been seeing the numbers of the attendees. Everybody's been glued on. So thank you very much, panelists, and thank you everyone for attending. If you have any more questions, inputs, we will be sending you an email with the recording for the session. We will also be uploading that on our website, which will be available to you in real time at any given point in time that you might need. So please feel free to reach out to us in the future. And we've got a lot of sequential webinars coming up from our leaders. So stay glued in to updates from our side. And thank you very much again. Thank you, panelists. Thank you, all the listeners. And we look forward to many more. Thank you.
Thank you so much.
Thank you. Bye.
Bye.
Thank you very much, everyone, for joining and listening patiently. Thanks a lot. Good luck.